Bem-vindos ao nosso espaço, um mergulho profundo nos assuntos mais interessantes de esportes, ciências e temas gerais do momento. Aqui você vai encontrar conteúdo de qualidade, com análises empolgantes e descobertas fascinantes que vão expandir seus horizontes. Nossa missão é trazer informação relevante de forma dinâmica e descontraída. Queremos que você faça parte dessa jornada incrível de conhecimento e diversão. Se gostar do nosso conteúdo, não esqueça de deixar seu like e se inscrever no canal para não perder nenhuma novidade. Ative o sininho também. Aproveite!
If you love science, don't forget to like and subscribe. Imagine a witness that never sleeps, never forgets, and records every detail of its environment for hundreds of years. This isn't a high-tech surveillance system, it's the forest surrounding us. While most people see tree rings as a simple way to tell a tree's age, forensic scientists see them as a biological hard drive. Welcome to the world of forensic dendrochemistry, where the wood under the bark acts as a permanent ledger for unsolved chemical crimes. Every year, as a tree grows, it adds a new layer of wood. This growth isn't just a physical expansion, it's a chemical snapshot. Trees drink from the groundwater and breathe the surrounding air. In doing so, they pull in minerals, nutrients, and, unfortunately, pollutants. These substances become locked into the cellulose and lignin of that specific year's growth rate. By analyzing these rings, scientists can create a year-by-year timeline of exactly what was in the soil and water at a specific location, often going back centuries. This technique is revolutionizing how we investigate environmental crimes. Traditional soil or water testing only tells us what is happening right now. If a factory illegally dumped toxic waste into a river 20 years ago and then cleaned up the site, a standard soil test might come up empty. However, a tree growing along that riverbank would have absorbed those toxins 2 decades ago. The proof isn't gone, it's simply buried under 20 layers of newer wood. To unlock this data, researchers use a tool called an increment borer. This allows them to take a pencil-thin core sample from a living tree without causing it any permanent harm. Once back in the lab, they use advanced techniques like inductively coupled plasma mass spectrometry or X-ray fluorescence. These tools can detect trace amounts of heavy metals like lead, mercury, arsenic, and cadmium. Because each ring corresponds to a specific calendar year, the scientists can point to a precise moment in history and say, this is when the contamination began. This biological evidence has been used to settle massive legal disputes. In one famous case, dendrochemists were able to prove that a specific manufacturing plant had been leaking chlorinated solvents into the groundwater long before they claimed to have started operations. The tree rings showed a sudden spike in chlorine isotopes that matched the plant's production schedule perfectly. It was a smoking gun that didn't require eyewitnesses or paper trails. But it's not just about heavy metals. Trees also record atmospheric changes. They can capture radioactive isotopes from nuclear tests or carbon spikes from massive industrial shifts. This makes them invaluable for tracking the long-term impact of forever chemicals, like PFAS, which are notoriously difficult to track because they don't break down easily in the environment. The forest becomes a spatial map of a crime scene. By sampling trees at different distances from a suspected leak site, investigators can calculate the plume of the pollution, how it traveled through the soil, and which way the groundwater was moving. This allows them to reconstruct the entire history of an ecological disaster that might have been forgotten by the public. Of course, the process isn't without its challenges. Scientists have to account for how different species of trees process chemicals. Some trees are fast drinkers that absorb everything quickly, while others are more selective. Some chemicals can also migrate slightly between rains, though forensic experts have developed complex mathematical models to correct for this smearing effect. Despite these hurdles, the accuracy of dendrochemistry is astounding. It bridges the gap between biology and law enforcement, turning the silent giants of our parks and forests into the ultimate whistleblowers. As we move into an era where environmental protection is more critical than ever, these botanical archives provide a level of accountability that was previously impossible. They remind us that nature keeps its own records, and while humans might try to hide their tracks, the trees are always watching, always recording, and always ready to tell their story to those who know how to listen. The next time you walk through a forest, look at the bark of an old oak or pine. You aren't just looking at a plant. You're looking at a living library of our planet's chemical history, a witness to every secret we've ever tried to bury in the earth. Forensic dendrochronology is proving that in the eyes of the forest, no crime is truly buried forever. For more incredible facts like this, don't forget to subscribe and turn on notifications.